Good morning, good evening, good afternoon, good whatever time of day it is, and whatever part of the world you're at right now. Welcome back. And today we're going to be doing another geometry lesson about similar triangles. So, if you've watched my previous videos on congruent triangles, similar triangles are similar because they share a proportion. Okay, congruent triangles, everything about congruent triangles are the same. The angles are the same and the sides are the same. Similar triangles are proportional to each other. So if we set up the correct proportions, those proportions should be equal to one another. When they're not equal to one another, they're not similar. However, for all three of these examples here, we're told that all of the triangles are similar, okay, in each example. So we should be able to establish proportions and then solve those proportions, okay? So one way to verify to make sure that you get your proportions correct is to set it up as such. So for example, if I start off with I'm gonna start off with the triangle on the top, DEF, right? And if I want to just focus on this expression right here, 9x minus 13, that is for DF, okay? So DF, right? And I want to set my proportion up so I have DF over a part of the smaller triangle, okay? Which that corresponds to DF in the smaller triangle corresponds to GF in the smaller triangle. So these two here, let me use a different color, GF, right? Which is 15. Okay, and that should be equal to, now let's say if we did the other piece of DEF, the 90, right? That's EF or FE. So EF, and let me erase these markings. So E to F is the same as H to F. So H to F, which is 27. So now, when we set up our proportion, we should have something that looks like this. 9x minus 13 divided by 15 is equal to 90 divided by 27. And now we're going to go ahead and just solve this proportion and find the value of x. So when I rewrite it, I'm going to have 9x minus 13. I'm going to simplify my fraction. Over equals 10 over 3. Now we can go ahead and cross multiply. So I'm going to do 3 times this group here. Okay. And then we're going to do 15 times 10. Okay. So on my next line, you're going to see me have 3 times 9x minus 13 equals 10 times 15. So that's going to give me 27x minus 39 equals 150. Then we're going to add 39 to both sides. So that's going to leave us with 27x is equal to 189. And the last, we're going to divide both sides by 27, and x will equal 7. So that's how you solve or find the value of x or some missing term when you're dealing with similar triangles. Okay, so now I'm going to do the same thing with the next example. So first, I can start off with PQ, right? PQ is the same as TS. So I can do PQ over TS is equal to, and then I use a different color, PR. So PR is the same as what? TU. Okay. So PR is similar to TU. Now we can go ahead and write out our proportions. Get rid of all of this and write our proportion out. So I'm gonna have 7x plus 2 divided by x plus 8 is equal to 35 divided by 14. And now we're going to go ahead and reduce that fraction and cross multiply. So I'm going to have 7x plus 2 divided by x plus 8 is equal to 5 over 2. Because we divide both of these can be simplified by 7. Okay, just in case you were wondering, both of these can be divided by 7. In the first example, I divided both of the numbers by 9. Okay, and that's how we ended up with 10 over 3. All right, so going back down to number 2, now if we finish, we got to cross multiply. So that's going to be 2 times 7x plus 2 equals 5 times x plus 8. So that's going to become 14x plus 4 equals 5x plus 40. Subtract 5x from both sides. That's going to become 9x plus 4 equals 40. Subtract 4 from both sides. That becomes 9x equals 36. And then divide both sides by 9. X is going to be equal to 4. Okay? And we're done. All right? So as you can see, similar triangles is all about setting up the correct proportions. Now, for an example like number 3, because both triangles, one triangle is kind of built into the other, I would first start off by saying redraw them. It doesn't have to be the biggest, just so you can get your visuals correct. Okay, so that's one triangle. Here's the other triangle. All right, and now I'm just gonna label the parts. KL is 4x minus 12, and JL is 2x plus 9. For the smaller one, ML is 24, NL is 21. And now we can kind of see the parts that correspond to each other. So for this one, this would be KL, over JL is equal to ML over NL. So that's going to give us 4x minus 12 divided by 2x plus 9 is equal to 24 over 21. Okay. Now, once again, I'm going to go ahead and simplify that fraction. Okay, so that's going to become 4x minus 12 over 2x plus 9 is equal to, both of those can be divided by 3, so that's going to be 8 over 7. Now I'm going to cross multiply, so this is going to become 7 times 4x minus 12 equals 8 times 2x plus 9. All right, now that we've done that, go ahead and finish working this out. That's going to become 28x minus 84 equals 16x plus 72. And just to make sure we know what we're doing, for this one, they want us to find JL. Okay, so after we find X, we're going to have to plug X into JL for our final answer. Okay, so now let's get back to working this out. We're going to subtract 16x from both sides. So if I subtract 16 from 28, it becomes 12x. So 12x minus 84 equals 72. Then I'm going to add 84 to both sides. So that's going to become 12x equals 156. And when you divide both sides by 12, x is equal to 13. Now, that's not our final answer. They want us to figure out what JL is equal to. So for JL, remember, JL, let me put it right here. JL is equal to 2 times 13. Let me rewrite that 2. Looks like a Z. 2 times 13 plus 9. 2 times 13 is 26. And 26 plus 9 is 35. So our final answer here, JL is equal to 35. Okay. All right, and that will conclude our little lesson on similar triangles and the use of proportions to solve those triangles. All right, have a good day and see you all back later for the next lesson.